In today's video, we learn about initial value and boundary value problems. Initial value problem IVP. A differential equation together with subsidiary condition on the unknown function and its derivatives, all given at the same value of the independent variable, constitutes an initial value problem. That's an IVP. In this example, we have the first subsidiary condition given at x is equal to 0, and we have the second subsidiary condition, that's y prime, at x is equal to 0. We call this guy an initial value problem since the values of the independent variable in the subsidiary condition are all given at the same point, that's x is equal to 0, x is equal to 0. Boundary value problem. If the subsidiary conditions are given at more than one value of the independent variable, the problem is called a boundary value problem. In this example, the value of the independent variable in the first subsidiary condition is given at 0, and the value of the independent variable in the second subsidiary condition is given at 1. In this case, we call this problem a boundary value problem. Question number 1. We have to determine if the given problem is an IVP or a BVP. So we have the differential equation given as y double prime plus 2y prime is equal to ex, and the subsidiary condition given as y of pi is equal to 1 and y prime of pi is equal to 2. So here we focus on the subsidiary conditions, right? So we have the value of the independent variable defined at pi, and we also have the value of the independent variable in the second subsidiary condition defined at pi. So these two values start at the same point, that's pi. This question is an IVP. So our second question, we focus on the subsidiary conditions. So in this case, we have y of 0 is equal to 1 and y of 1 is equal to 1. So the first subsidiary condition, we have the value of the independent variable defined at 0, and in the second condition, we have the value of the independent variable defined at 1. So we have 0 and 1. So since the values are different, we call this guy a boundary value problem. Our third question focuses on how to determine the particular solution from the general solution given a subsidiary condition. Thus, how do we eliminate the constants in the general solution? So our third question is find the particular solution of the differential equation whose general solution is given as y is equal to c1 e exponent minus 2x plus c2 e exponent 5, subject to the condition y of 0 is equal to 2 and y prime of 0 is equal to 5. Solution. So we have y of 0, that's when x is equal to 0, the value of y is equal to 2, and y prime of 0 is equal to 5. So we first have to differentiate y in order to get y prime. So now let's differentiate y. Y prime will be given us, here we are differentiating an exponential function, right? So you differentiate the exponent, then you multiply. And so we are going to have minus 2 c1 e minus 2x plus 5 c2 e 5x. So let's call this guy say equation 1 and this guy say equation 2. So from the first subsidiary condition, we have y of 0 is equal to 2. That's when x is equal to 0, the value of y is equal to 2. So we are going to substitute x is equal to 0 and y is equal to 2 in equation 1 because that's the y equation, right? And so we are going to have 2 is equal to, so x is non-zero, so we are going to have c1 e minus 2 times 0 plus c2 e 5 times 0, which will be simplified to e c1 plus c2. So we call this guy say equation 3. Also, from our second subsidiary condition, we have y prime of 0 is equal to 5. Thus, when x is equal to 0, y prime is equal to 5. So we substitute x is equal to 0 and y prime is equal to 5 in our second equation. So we are going to have 5 is equal to minus 2 c1 e minus 2 times 0 plus 5 c2 e 5 times 0, which will be equal to 5 is equal to minus 2 c1 plus 5 c2. So we call this guy say equation 4. Let's have to solve equation 3 and equation 1 for C1 and C2. Now let's choose equation 3 and make C2 the subjects. So from equation 3, we are going to have C2 is equal to 2 minus C1. So we call this guy equation 5. Substituting equation 5 into equation 4 gives 5 is equal to minus 2 C1 plus 5 times C2. But C2 from equation 5 is 2 minus C1. Now let's simplify this. So that's going to be 5 is equal to minus 2 C1 plus 10 minus 5 C1. So this is going to be minus 5 is equal to minus 7 C1. And so we are going to have C1 to be giving us 5 on 7. So let's call this guy, say, equation 6. So now our next goal is to find C2, right? So we can find C2 from equation 5. So we just have to substitute C1 is equal to 5 on 7 in equation 5. Then we are going to have C2. From equation 5, we are going to have C2 is equal to 2 minus C1, which is 5 on 7. Thus, we have C2 to be 9 on 7. So we now have the values for C1 and C2. So our next step is to go back to our given general solution, which is giving us y is equal to C1e minus 2x plus C2e exponent 5x. So now we have C1 to be 5 on 7, C2 to be 9 on 7. So we just have to substitute these guys in here. Then we are going to have our particular solution. And so our particular solution will be giving us y is equal to 5 on 7 e minus 2x plus 9 on 7 e 5x. And so this is our particular solution. With example 4, we have to find the particular solution of the differential equation whose general solution is y is equal to C1ex plus C2e exponent 3x, subject to the condition y of 0 is equal to 3 and y prime of 0 is equal to 4. As we did in our previous example, since we have y prime in the subsidiary conditions, we have to differentiate y in order to get y prime. So let's differentiate y. So y prime will be giving us minus C1e minus x plus 3C2e 3x. So we just have to substitute. So from the first subsidiary condition, when x is 0, y is equal to 3. So we substitute those guys in here. So x is now 0 and y is equal to 3. So we are going to have 3 is equal to C1 plus C2. Let's call this guy equation 1. Now we move on to the y prime subsidiary condition. So that's when x is 0, y prime is equal to 4. So we're going to have 4 is equal to minus C1 plus 3C2. Then we call this guy, say, equation 2. Then we have to solve this system of equations. So from equation 1, we can say that C1 is equal to 3 minus C2. We call this guy equation 3. Then we substitute equation 3 into equation 2. And so we are going to have 4 is equal to minus C1, but C1 is 3 minus C2 plus 3C2. So let's simplify. So that's going to give us minus 3 plus C2 plus 3C2. Simplifying this gives 7 is equal to 4C2. And so we have C2 to be giving us 7 on 4. So from equation 3, we have C1 is giving us 3 minus C2, and C2 is giving us 7 on 4. Thus, C1 is giving us 5 on 4. Now, our next step is to substitute these values into a general solution. So we are going to have y is equal to C1 is 5 on 4, then e exponent minus 1 plus C2 is giving us 7 on 4, e exponent 3x. So thus we have our particular solution given below. Question number 5. Find the solution to the boundary value problem. Y prime prime plus 4y is equal to 0. And the subsidiary condition giving us y of 0 is equal to minus 2, y of pi on 4 is equal to 10. If the general solution to the differential equation is known to be y is equal to c1 sine of 2x plus c2 cosine of 2x. Since we don't have any y prime, there is no need to differentiate this guy, right? So we just have to substitute these values into our general solution, then we solve the resulting system. And so when x is equal to 0, we have y to be minus 2. So we are going to have minus 2 is equal to c1 sine of 2 times 0 plus c2 cosine of 2 times 0. So this is going to give us minus 2 is equal to, now sine of 0 is 0, so this part will go to 0. Then cosine of 0 is 1, so we are going to have this guy to be c2, so which implies that c2 is giving us minus 2. Also, from our second subsidiary condition, we have when x is pi on 4, y is equal to 10. So we substitute these values into our general solution, and so we are going to have 10 is equal to c1 sine of 2 multiplying pi on 4 plus c2 cosine of 2 multiplying pi on 4. Now let's simplify this guy. So we are going to have 10 is equal to c1 sine of, now 2 times pi on 4 is giving us pi on 2 plus c2 cosine of pi on 2. Now cosine of pi on 2 is equal to 0, so this guy will go to 0. And so you're going to have 10 is equal to c1 sine of pi on 2. Sine of pi on 2 is giving us 1, and so we are going to have 10 is equal to c1. So we have our value for c1 to be equal to 10. So we substitute these values into our general solution. So our particular solution will be giving us y is equal to, so we had it to be c1, but c1 is now 10, then sine of 2x plus c2, but c2 is now minus 2, then cosine of 2x. And so this is our resulting particular solution. With our last example, we have to find the solution to the BVP y double prime plus 3y is equal to 0. So here we just have to substitute the points into a given general solution because there is no y prime, so we don't need to differentiate. So let's start with the first subsidiary condition. That's when x is 0, y is equal to 0. So we are going to have 0 is equal to c1 cosine of square root of 3. So x is now 0. So here will be 0. So that's square root of 3 times 0 plus c2 sine of square root of 3 times 0. So we are going to have 0 is equal to, so now cosine of 0 is 1. Then plus sine of 0 is 0. That's this part will go to 0. So thus we have c1 to be equal to 0. So we substitute our second subsidiary condition in. So that's when x is pi on 2 on square root of 3, y is equal to 10. And so we are going to have 10 is equal to c1, but we know c1 to be equal to 0. So there is no need to solve for c1 here. Then that will be c2 sine of square root of 3 times x. So x is defined to be pi on 2 root of 3. Now let's simplify this. So that's going to give us 10 is equal to c2 sine of, so in this case square root of 3 will cancel square root of 3, so that will be pi on 2. And so we are going to have 10 is equal to c2 because sine of pi on 2 is equal to 1. And so we have the values for c1 and c2. And so our particular solution will be giving us y of x is equal to, so we have it to be c1, but c1 is now 0. then cosine of square root of 3x plus c2, of which we know c2 to be 10, then sine of square root of 3x, and so y is equal to 10 sine of square root of 3x. And so our particular solution is given below. Thank you guys for watching. See you in the next video. Please make sure to subscribe and share with your friends.